Hello guys, welcome. Today's video will be the very first topical based video in the IGCSE mathematics syllabus, and that's a new category I've introduced on my website. And to start off, we're going to be starting with one of the basics that have already been taught in year 9, year 8 and year 7, and IGCSE is just reinforcing all the facts that we're learning. So if you're an IGCSE student, you will find this really useful. If not, if you're doing SPM, STPM or any other course, all of this comes under it. So this video will be under 4 sections. I will be doing 4 sections in this video, all in the same video of course. So after every section, feel free to pause the video, go through the concepts and then move on to the next section. It's a full video on its own, but it has 4 sections involved. So today's topic will be equations and transforming formulae. The first part of equation transforming formulae is expanding brackets. Okay, this is something that's incredibly easy. You can expand brackets. It's basically a piece of cake. We've done this long ago, and this is just like a revision to what you've already done. So if we can start with something like 10, 3p plus 6. Negative 10, open bracket, 3p plus 6. And they ask you to expand this. So what you have to do is, the first step to expansion is to multiply the number outside by the numbers inside. So negative 10 will be multiplied by 3p, and negative 10 will be multiplied by 6. So negative 10 times 3p is negative 30p. And negative 10 times 6 is negative 60, of course. So the answer is negative 30p minus 60. The rule of simplification or expanding the brackets is that you should never see the brackets again. The brackets will be in the question, but your job is to make it disappear. You have to expand it in such a way that it comes to this form where there are no brackets available. Okay, let's try something else now. Something maybe a bit harder. Let's see. There. Negative 3 q minus 12. Not that hard. It's quite easy. Negative 3 open bracket q minus 12. The first step, find a number outside and multiply the number outside by the number inside. So that will be negative 3q, and negative 3 times negative 12, negative cuts out. 3 times 12 is 36. So that gives us negative 3q plus 36. Okay? So this is expanded. Most of the simplification processes can only end with just one step. The whole thing just finishes it off. I don't think I need to reinforce on that anymore. That's incredibly easy. Just multiply the number outside by the numbers inside. It's as simple as that. So let's go to something a little more challenging perhaps, okay? So we have 3x, x minus 2, and we have minus x minus 2. We will have to bring this with no brackets. This function will have to lose all its brackets. All there should be no brackets in the answer. And there are 2 different brackets here, which should be solved individually. So to simplify this, what we have to do is take this number and multiply it inside. And here, since there are no values before the bracket, always assume it's a 1. When there's nothing there in maths, it's always a 1. So let's say there's negative x. They're not actually saying it's negative x. It's actually negative 1x. But they're just too lazy to put the 1. So what in maths, remember, before the variable, if there are no numbers, that means it's a 1. There's a 1 there. It's just an invisible 1. Okay, so just assume there's a 1 before the bracket. 3x, x minus 2, and negative 1, x minus 2. So let's start multiplying. 3x times x is 3x squared. 3x times negative 2 is negative 6x. So the negative 1 times x is negative x. Negative 1 times negative 2 is plus 2. Okay, then bring the right variables together. Both of these have the variable x. So do this. 3x squared minus 7x plus 2. That's all. Bring the right variables together, put everything together in the form. And when you present your answer, make sure the x variables are in descending order. So it's x squared, then there's x, then there's nothing, obviously. X is the smallest. So x to the power of 2 x to the power of 1, x to the power of 0. Because x to the power of 0 is obviously 1. So it's an invisible 1 over there. Just assume it's an invisible 1. Okay? This is simple. 2 brackets. Do each bracket individually. We'll do one more and then we'll move on. Let's see. Okay, 3x plus 1. And we have minus 2. We have 3 minus 2x. We're going to solve this function to make it one complete equation. So what we have to do now is multiply 2x, which is outside, multiplied by 3x, 2x multiplied by 1. Negative 2 multiplied by 3, and negative 2 multiplied by negative 2x. So 2x times 3x, 6x squared. 2x times 1 is 2x. Negative 2 times 3, negative 6. Negative 2 times negative 2x plus 4x. So it's 6x squared plus 6x minus 6. So that is a simplified version of this. Bring the right terms together. And this comes here. At the end, x to the power of 2, x to the power of 1, and x to the power of 0, which is 1. Okay, that is officially the last part. First part, sorry. That's the first part of solving basic functions. And if you want to learn more on this, check out the activities below. Okay, so now pause this video right now and just rewind a bit and see what you don't understand. And put it down in the comments below. So whatever you don't understand, just post a comment or email me. I'll give you the email later. This is the first part, expanding brackets. Okay, welcome back to the video, guys. This is our part 2. The one is still there, obviously. And in part 2, we are going to be looking at solving linear equations. It's still under the topic equations and transforming formulae. So when you're solving linear equations, you're predominantly asked to find the value of the unknown variable. It can be a, b, c, d, e, anything under x, but x is the most common one, so we're using x. And the definition of a linear function is anything that does not have a cube. There are no power of 3, no cubes inside a linear equation. There are no roots. There are no irrational numbers like this, like recurring decimals, none of that. None of this is in a linear equation. A linear equation is only the power of 1. A quadratic equation is the power of 2. And a cubic equation is to the power of 3. But that's all later. We're solving linear equations now. And you are supposed to find the value of the unknown variable, which is x. In a linear equation, you only have one variable, unless you're doing it simultaneously. So one variable. So let's, I put here 3 different types of questions which we will solve, okay? So the first step in solving a basic linear equation is to isolate like variables to one side. So let's keep the left hand side, the LHS, left hand side for the x variables, and let's keep the right hand side for the numbers, okay? So let's keep the 4x on this side, and let's bring this 3 to this side. So that's 4x equals 31 minus 3. So 4x equals 28. Obviously 31 minus 3 is 28. Then just divide both sides by 4 to find the value of x. You get rid of 4 on one side. So 28 divided by 4 is 7. So x equals 7. It's easy as that. We can solve this in 3 basic steps. Bring all like variables to one side. So I'm going to bring all numbers to this side. Keep the x variable on this side. Then do the calculations for x equals 28. And then you get x equals 7. So that's simple. That's done. Let's move on. This is slightly more complicated because it has a fraction. And when you have a fraction in a linear equation, it can cause problems because you can't just reverse it easily and do this sort of process. You have to get rid of the fraction. And in order to get rid of that fraction, you have to multiply all sides, like every variable by 3. So what you have to do is to, like for the 3, let's say when you have 1 over 3 times 3, the 3 cancels out, making it 1. That's exactly what we're going to be doing here. We're going to be multiplying both sides by 3 to get rid of a fraction. So 3, 2x plus 3 plus 1, and 3, 8. just 3 and put the LHS and the RHS in brackets. So we have to work this out. So when we work this out, just removing brackets, the 3 and the 3 cut off, making it only a 2x. The 3 and the 1 give us a 3, and the 3 and the 8 give us a 24. So 2x equals 24 minus 3, which is equal to 21. Obviously, 2x plus 3 equals 24. 2x equals 24 minus 3. So 2x equals 21. So that's x equals 21 over 2. And when it's an improper fraction like this, you change it into a mixed number or a decimal, depends on what the thing asks. Most of the time it will ask you in a mixed fraction. If it doesn't tell you anything, present the answer in a mixed fraction to be on the safe side. So converting this to a mixed fraction, basic maths, 10 1 over 2. So x equals 10 1 over 2 in this thing. For us to get 2x over 3 plus 1 equals 8. So multiply both sides by 3 to get rid of the fraction. As you can see from here, in this step, we've removed the denominator. It's all just single. There are no bottom numbers, the denominators. It's all just whole numbers. Whole numbers and an algebraic equation that allows us to solve this equation like this. So multiply both sides by the denominator to get rid of the denominator, and then find the value of x by basic linear functions. Okay, that's number 2 done. Number 3. So now how are we going to approach something like this? There are x on both sides, and this makes it ridiculously complicated again. What we have to do, first step, is remove the denominator. No one likes denominators, it just causes a mess. So to get rid of it, as I told you before, we need to multiply both sides of this equation by 2. So 2x over 3 over 2 equals 2x. So 2 and the 2 cancel out, giving us x plus 3, and 2 and the x multiply to form 2x. Like I said before, bring all the right terms to one side. So I'm going to perhaps keep the x variables on the left hand side and the numbers on the right hand side. Let's do that. X minus 2x equals negative 3. So bring this side, bring the 2x to the LHS. So x minus 2x is negative x, and negative x equals negative 3. So x equals 3. It's as simple as that. There's nothing complicated. X equals 3. 3 basic ways of solving a linear equation. And I'm going to do one more complicated sum before we close this thing and we move on to section 3. Okay, one more complicated sum. Which one can we take? Okay, we'll take this. 4 plus 2 minus x equals 3 minus 2, 5 minus x. Okay, simple as that. We need to remove the brackets and then we do some basic editing, okay? Editing and calculations. It's all just fun. So 4 plus 2 minus x. Simple. We need to simplify both sides first and then bring all the right terms to one side and all the other right terms to the other side. So 4 plus 2 times 2, 4. 4 plus 4, 2 times negative x, negative 2x equals 3. Copy the 3. Minus 2 times 5 is 10. Negative 2 times negative x is plus 2x, obviously. Okay? And then just work out both sides first. So 8 minus 2x equals negative 7 plus 2x. So let's say you can choose wherever you want. I am a big fan of the left hand side, so I'm going to keep my x variables on the left hand side. But you can choose to do it on the right. It makes no difference. The answer is always the same. So I'm going to bring all the x variables to one side and the y variables to the other side. So negative 2x minus 2x equals negative 7 minus 8. So that's negative 4x equals negative 15. And cut the minus and minus cut off. So 4x equals 15 and x equals 15 over 4. Which is 4, 3, 12, 2 over 4. So that's 3, 2 over 4, wait, that's 3 over 4, sorry. 4, 3, 12, 12 plus 3, 15. 3 over 4 is the value of x. And in a basic linear equation, you can substitute the value of x to see whether the LHS, the left-hand side, equals the right-hand side. If it does equal each other, that means your x value is correct. But if it does not equal to each other, the left-hand side and the right-hand side, that means you've done something wrong. So go back and check your working, or in the worst case, redo the whole sum. Okay, that's basically it. That's how we solve for functions, linear equations. It's extremely easy. I'll upload some sums onto the site for you guys to try. I'll even find a worksheet for you. So pause the video right now and we will move on to section 3 shortly. Okay, welcome to section 3. I keep forgetting to change that part. The section 3 of equations and transforming formulae. So when you're factorizing algebraic expressions, you've probably heard the word factorizing before. You can watch the middle school maths videos on factorization. So go back to that and watch that video on factorization and expansion. So this is something different. We're factorizing basic linear, no, this is not linear, this is quadratic. We are factorizing algebraic expressions, not linear, not quadratic, it's all mixed up. So the first step is to do 3 sums, so we're going to do 3 sums anyway. And the fourth sum is a challenge, we'll do that later. So 15x plus 12y. To factorize this function, we first need to find out what is common between 15 and 12. X and y are not common, it has to be in both. So x and y stay where they are. So what's common between 15 and 12? You will have to find the highest common factor, HCF. What is the highest common factor between 15 and 12? And the highest common factor is 3. Yes, 3. So 3 stays outside and 15x. So we need to divide 15x by 3 to find out what comes inside. So 3 times what gives us 15x? 3 times what gives us 15x? 3 times 5x gives us 15x. So obviously 5 times 3 15 and the x stays there. So 3 times 5x gives us 15x. And then we need to see 3 times what gives us 12y. So 3 times 4y equals 12y. So plus 4y. After that, we need to, yeah, that's it. That's the answer anyway. 5x plus 4y. That is the answer. We just factorize it. Just remove what's common between both of this, and then you will find the factorized version of this. Over here, find what's common between 18mn and 30m. Okay, m is common. There's m present in both of this. So m can be one common. And what is common between the numbers 18 and 30? The highest common factor of 18 and 30 is, yes, 6, you're right. 6. And just keep the m outside the bracket. Whatever is common stays outside the bracket. Whatever can't be common stays inside the bracket. So 6m times what gives us 18mn. So the m stays, so you don't need to multiply it. So 3n. 6m times 3n gives us 18mn. 6m times what gives us negative 30m. So the m stays the same, so we need to divide 30 and 6, which is 5, yes. Which is 5. So 6m, open bracket, 3n minus 5. If you simplify this expression, you will come back to this. When you're simplifying expressions is the opposite to factorizing them. So the question becomes the answer here, and there the answer becomes the question. So factorizing and simplifying are total opposites. Okay? So bring what's common outside, leave what's not common inside. And third sum, slightly more complicated. These two are both linear equations, and no powers and no roots. Here there are powers, both the power of 2. Let's see. What's common between 36 and 24? Go from the start. The highest common factor of 36 and 24 is 6. Yes, you're right. Again, you're right. It's 6. So 6. And what's common between p squared q and pq squared? It's pq. Pq is common between this because there's 2 p's and 1 q here. There's 1 p and 2 q's. and PP, PP, and Q, and on this side there was P, Q, Q. So I'm putting in very direct orders for you. What's common? P is common, and Q is common. The rest of it is not common, so P and Q. So what's common? What's these be outside the bracket is P and Q. So open bracket. 6PQ times what gives us 36P square Q. So 6P. 6 times 6 is 36. So 6P minus 6PQ times what gives us negative 24PQ square. So what 6 times what gives us 24? That's 4. And P stays the same, so it's another Q. Minus 24PQ square. Okay? So that's what's taken out. But we can simplify this even more. 6 and the 4 still have a highest common factor, and that is 2. So we can take it again. 12PQ, and take out 2 this time. 3P minus 2Q. Here itself we have taken out 12. So I made a mistake by choosing 6, and then when there's still something common inside the bracket, you do it again until there's nothing common inside the bracket. So this is the factorized form of 36P square Q minus 24PQ square. If you're a first time learner of this, then you might feel a bit confused, but if you have already been taught this in school, it might be a little less confusing. Okay, now to the harder part of factorization. We got away with the easy bits now. Now let's go to a slightly harder part of it. Okay, 15x minus 2, and we have minus 20. X minus 2 whole square. Now that is something a bit more challenging. Now how are you going to factorize something that already has brackets? Okay, factorizing is supposed to give you 2 equations with brackets, but there are already brackets in this. How are we going to factorize this? You have to look at this in a totally new approach. You have to find what's common between the whole equation, not only one part of it. So what's common between 15x minus 2 and 20x minus 2 whole square? First of all, start with the numbers. 15 and 20, what's common? What's common between 15 and 20 is 5. So take 5 outside. Okay? And then what's common between x minus 2 and x minus 2 square? I'll put this again in this form for you. X minus 2 on the LHS, and x minus 2, x minus 2. So what's common? Cut, cut. 1x minus 2. So x minus 2, and then open one nice gigantic bracket. That's a bigger form of bracket. Very nice, right? Nice big bracket. And then see, 5x minus 2 multiply what gives us 15x minus 2. So 15 and 5, x minus 2, x minus 2 is the same, so I'll leave that. 15 and 5, 5 times 3 gives us 15, so put the 3 over there. 5x minus 2 and 20x minus 2 whole square. What times 5x minus 2 gives us negative 20x minus 2 whole square? And the answer to that is a positive 4. Sorry, negative 4, sorry, it's a negative. So negative 4. And since we need to multiply one more x minus 2 to make it a square, x minus 2. Okay? But you have to think for yourself again. This is another way of doing it. If there's a big complex function, this is how you factorize it. Okay? The HCF of 15 and 20 is obviously 5. And the HCF of x minus 2 and x minus 2 square is obviously x minus 2. Because 5x minus 2 times 3 is equal to 15x minus 2, and 5x minus 2 times negative 4x minus 2 is equal to negative 20x minus 2 square. This way of doing it makes sense now. Okay? If you need one more example, put a comment below, and I will do that before I move on to my next video in the next time publish a video. Okay? Because we can't spend too much time on this. We still have to move on to our reversing the formulas, rearranging. That's the last part of the section. But if you still need additional guidance, just email me or drop a comment below. Thanks. Okay, welcome back, guys. Now we are going to be doing transformation of a formula. We need to change a expression or an equation. This is an equation because it has the equal sign in terms of this value. So we need to put this as b equals the rest of the variables, and in this we need to put a, and in this let's use something x1 plus z over t. Let's make it complicated. Let's put z, okay, to make it more challenging. We need to put b equals something, a equals something, or z equals something, okay? We need to change it into terms of these algebraic expressions, okay? So now we need to isolate b on one side and move all the other variables and numbers to the other side, because it has to be in terms of b, which means b equals something else. So b equals a comes to the other side, c minus a. That's all. That's how we move this equation in terms of b. So b equals c minus a. Leave b on one side and bring all the algebraic expression and the numbers to the other side. So b equals c minus a. That's as simple as that. Now it's something more complicated. Now with brackets in this. Okay? So now we need to move this into terms of a. Don't bother simplifying this brackets, removing the brackets and then doing it. It's way too complicated. There's an easy way to do this. To leave the left hand side with only a, we need to get rid of this n minus m. We don't like it. We want to get rid of it from the left hand side. The left hand side should only have a. So we need to divide both sides by n minus m. Okay? So divide both sides by n minus m, or we can multiply both sides by 1 over n minus m. So a n minus m times 1 over n minus m, and t times 1 over n minus m. Okay? So here n minus m and n minus m cancel out, and you have isolated a to the left hand side successfully. So a stays there, and then t times 1 is t, so t over n minus m. So this equation is now in terms of a. You've tried to remove the bracket by multiplying both sides by 1 over n minus m. That's one way of doing it. Now let's move on to fractions. We've done basic, brackets, now fractions. The examiner asks you to make this equation in terms of z. But the z is on the denominator, which makes it harder. I can't just multiply both sides by z and straight away produce an answer. So here what you have to do is, first of all, remove the denominator. As I said before, people don't write denominators. They just want a top. So multiply both sides by z to get rid of it. So xy over z times z equals t times z. Okay? So z and z cancel out. Xy equals tz. Okay, the side that has tz, reverse it the other side. So bring this to this and here to here. So LHS becomes the RHS, the right hand side becomes the left hand side, and the left hand side becomes the right hand side. Whatever has z becomes the left. So tz equals xy and z. We need to make this in terms of z. And in order to do that, we need to get rid of this t. This is unwanted stuff. We need to move it to the right hand side. So as I said before, multiply both sides by 1 over t. The t and the t cancel out. And z equals xy over t. You have successfully isolated z to one side, and z equals xy plus t. That's exactly how you solve how you transform a formula into terms of what they give you. Okay? So now let's move on to something harder. We've done transformation with basic stuff. Now let's add roots inside. Roots make the whole thing complicated. The roots make the whole situation complicated. So x over root y equals c. And they, of course, they would ask you to do this in terms of y. And they'll put what you want to do it in terms of in brackets, okay? So now, most people struggle with this sort of sums. As soon as they see this root, they start to panic. But it's not the end of the world. There's always a strategy for solving this kind of sum. If you remember from year 9, any root squared, so root y squared will give us a y. A root y times a root y is a y. So to get rid of the roots, we need to square both sides. So just square both sides completely. That's the advantage of an equation. You can, whatever you do for both sides, which means you can immediately eliminate whatever you don't want. So x over root y square and c whole square. So do it individually. X square is x square, root y square is y, c square is, obviously c square. And we need to change this in terms of y. So we have this, we removed the root. This funny thing has gone. The square root has gone away. So now the next problem is there is a fraction. And when there is a fraction, we must get rid of the denominator. So what I said before, we need to multiply the denominator both sides. So x square over y times y equals c square times y. Y and y cut off, x square equals c square y. Reverse it, whatever has c square, the RHS becomes the LHS and the left hand side becomes the right hand side. So c square y equals x square. And then to make y isolated on one side, we must remove this unnecessary c square. So multiply both sides by 1 over c square. Or divide both sides by c square, you can do whatever things. So c square y over c square, c square y over c square equals x square over c square. So the c square and the c square cut off to make y equals to x square over c square. There we go. Y equals x square over c square. Now this is how we transform a harder formula with square roots. You square both sides, you remove the denominator by multiplying the denominator both sides of the equation, and then you simply work it out. So one last one for us to end this video. So the last sum we're going to be doing today is this, a whole root, and we need to change this in terms of b. Square both sides. First step, square both sides. Very quick. So x minus b whole square is x minus b, because root x minus b times root x minus b is obviously x minus b whole squared. And c squared is c. C squared is c squared. So we need to change this in form of b. So bring b to one side. Since it's a negative, as just bringing it to this side. So b equals, bring c squared to this side, x minus c squared. Right hand side becomes left hand side becomes right hand side. Okay, so now just we need to bring it the other way around. So b equals x minus c squared. It's the same thing. X minus c squared equals b, and b equals x minus c squared is the exact same thing. And this is how we reverse it. Whenever you find the root, I give you one tip. Just square both sides completely. And if there is still a fraction, multiply the fraction both sides. Okay, to get rid of it. Always remember, the rule of transformation of a formula is to first get rid of all these fractions. Denominators are a waste, we don't want them. It just makes the whole sum difficult. Number 2, get rid of the roots by squaring both sides. Because a root squared is it gives us a number inside. Okay, so just get rid of roots and get rid of denominators, and you will be fine for now in IGCSE. Okay, thank you guys. That is the end of this video, equations and transforming formulae. It is in 4 sections, which you will see on my site right now, all in one video. So if you have any doubts, please check out my website mathsforgeeks.org on the screen right now. And we have my YouTube channel, youtube.com/c/mathsforgeeks, and my Facebook page for latest updates, facebook.com/mathsforgeeks. Thank you for watching, guys. This is the best. Thanks a lot for watching.